All right, lesson 7B about sampling distributions and test statistics. So first, some definitions. All right, sample statistic. We've already talked about this all the way back in Unit 1. If I take a sample from a population and I calculate some statistic, mean, standard deviation, proportion, percentage, variance, any of those things that we can calculate, those are sample statistics. So let's say, for example, I took a sample of 50 Patriot students. The whole school, it's just a group of 50. Their average GPA was 3.14. That's a sample statistic. The proportion of students who were in at least one AP class was 0.41. That's a sample statistic. Okay? So, talked about this back in Unit 1. And then we have a sampling distribution. Okay? Now, the official math definition. The population distribution of the test statistic when we take multiple samples from the population. Sounds like a whole bunch of gibberish. Here's what it really means, okay? I have a sample of 50 Patriot High School students, okay? There's a whole bunch of different ways that I could take those 50 students, right? There's a whole bunch of different groups of 50 that I could take out of the 2,100 whatever students go to Patriot, okay? So if I take all of the different ways that I sample 50 students, all right, and I record their mean GPA, that is a sampling distribution, okay? I am looking at all of the different means based on different groups of 50 students from Patriot High School, okay? So we have something called the sample limit theorem, all right? And that says if your sample size is than or equal to 30, okay? So like the last time we were talking about taking samples of 50. Then the sampling distribution of the means, all of the different means of all different sample groups that you could take, is normally distributed. Okay? Normally distributed means that it follows those rules that we talked about in Unit 5 when we had the normal distribution. Okay? And that 68% are within one standard deviation. 95 within 2 standard deviations. So all these little percentages that we did in Unit 5. Okay? As long as my sample size is greater than 30, then all of those different means from all of those different samples are going to follow the rules of the normal distribution. Okay, so what this means is that we can use what we learned in Unit 5 about finding z-scores and using the z-table to calculate different probabilities. All right, so when our sampling distribution is normally distributed, we know some things, okay? The mean of our sample, okay, that's U of X means the mean of our samples is equal to the mean of the population. Okay, so if we know the mean of all of Patriot High School's GPA, then if we took the means of all of our different sample means, it would equal the same as the whole population. Okay. The standard deviation, all right, and you might hear this called the standard error for distribution. So for all of those different means that we found, okay, it's going to be equal to the standard deviation of the population divided by the square root of n, okay, and n is our sample size. All right, so these are some formulas that we need because what we're going to do is find z-scores. All right, we're going to find z-scores and use the table to find probabilities just like we did in Unit 5. All right, so let's look at how to find probabilities. It's going to be very similar to what we did when we did the normal distribution. Okay, so the mean GPA for all Patriot students is 2.72 with a standard deviation of 0.89. By the way, I totally made that up. I have no idea if that's accurate or not. Okay, so if we take a sample of 50 students, what is the probability that the mean GPA of our sample, of our 50 students, is less than 3, more than 2.5, between 2.5 and 3.0. Okay, so we did z-scores here. All right, so I gave you a formula for z-score, and we're using standard error because we're taking a sample All right, and remember we just talked about the formula for standard error is standard deviation divided by square root of n. So that's the first thing I'm going to do is I'm going to find my standard error. Okay, so the standard deviation for all of Patriot is 0.89 divided by the square root of my sample size, and I'm taking a sample of 50. Okay, so my standard error here, and I'm going to take it out to 3 decimal places, so it's going to be 0.126. Okay, so now this is exactly like what we did in Unit 5. So if it's less than 3.0, I need the z-score for 3.0. So z is going to be x, which is 3, minus the mean, which is 2.72, divided by the standard error, so I'm going to use that 0.126 number. Okay, that gives me a z-score of 2.22. Okay, and then I want the probability, so I'm going to go to my z table and look for 2.22. All right, and I know this might be a little bit hard for you to read. I have it way zoomed out, but you have access to this table, so you can see it yourself. So my z-score is 2.22. So I go to 2.2 and then over 2.02, and the number there is 0.9868. Okay, and since it says is less than, we use the probability from the table. So 0.9868. That's the probability that my sample of 50 students have a mean GPA less than 3.0. Okay, is more than 2.5. So again, I need a z-score. So my z-scores are going to be equal to x, which is 2.5, minus the mean, divided by my standard error. My standard error stays the same here because I'm still using that sample of 50. All right, so my z-score is going to be negative 1.75. All right, so I'm going to go back to my table. I'm going to look for negative 1.75. All right, so negative 1.7. I go over to 0.5, and I get 0.0401. Now, remember from Unit 5, then. So if I want more than, I have to do 1 minus this number. Okay, 1 minus the number from the table, and that would give me 0.9599. So there's about a 96% chance that the GPA of my sample is going to be more than 2.5. All right. Then part C says between 2.5 and 3.0. All right. Now, I already have probabilities for those. Okay. Remember, we would do the z-score 2.5 and 3.0, which we already found. Then we would get the probabilities from the table, which we already did. And then we would subtract the two. Okay. So 3.0 is 0.9868. 2.5, I'm taking the table number, not the one I subtracted. All right, so 0.0401, and that gives me 0.9467. There's a 94.67% chance the GPA of my sample of 50 students is between 2.5 and 3.0. Okay, next thing we're going to look at is that same process but for proportions. So remember we talked about what percent students are taking at least one AP class. Okay, to use the z-test for means, as long as n is greater than 30, it's normal. Okay, so that's the rule for means. The rule for proportions is that NP and NQ have to be greater than or equal to 5. So we'll talk about what this means in our examples. And if both of these conditions are met, then the standard error for population, all right, the population standard error formula is the square root of P times Q over N. All right, P times Q over N. That's how we find standard error to use in our z-score formula when we're talking about population or proportions. All right, so let's look at an example here. Let's say that in all of Patriot, 47% of the students take at least one AP class. Okay, so first, let's make sure that our sample is going to be normally distributed. So we have to use our NP and NQ rule. So NP, all right, P is going to be the probability that someone takes an AP class. Okay, so it's going to be 50 times 0.47. All right, because that's our probability of taking an AP class, and that's going to be 23.5. That is bigger than 5, so that's good. Now let's check NQ. Okay, so Q, just like when we did our binomial probabilities, Q is going to be the probability that someone does not take an AP class. So that's going to be 1 minus 0.47 or 0.53. All right, when I do that, I get 26.5. So our NP and NQ numbers are bigger than 5. So that means normally distributed, which means we can use this rule for the standard error. All right, so let's go ahead and find that standard error. Okay. All right, so our standard error is the square root of P, which is 0.47, times Q, which is the 1 minus P, all right, over N, and our sample size is 50. So when I do that, 0.071. So that is my standard error. That's what we're going to use on the bottom of our z-score calculations. Okay, so what's the probability? If I take my sample of 50 students, that less than 40% of them take at least one AP class. All right, so let's find our z-score. So z-score is x, and our x is going to be 0.40 because we want 40%, minus p, which is the population percentage of 0.47%, over standard error, which we calculated as 0.071. And so the z-score that I get here is going to be negative 0.99. All right, then I go to my table. All right, for negative 0.99, the probability there is 0.1611. Okay, so there's about a 16% chance that my sample of 50 students will have less than 40% of them taking at least one AP class. Okay, so that would be my answer there. More than 50% take one AP class. All right, so same thing, z-score. All right, 0.50 minus 0.47. And same standard error because my sample is still 50 students. And when I do that, I get 0.42 as my z-score. All right, so my table, I'm going to find 0.42, and the probability there is going to be 0.6628. But remember, on the table, that is a probability, more than probability. I'm going to do 1 minus that number, and so that is going to give me 0.3372. All right, and then next time we'll see how this fits in with our hypothesis testing.